Okay, my dear friends. Now, today, once we will recap what we have studied in the last class, so that it will be connectivity with the our class. Now, then after that, we will start our today's lecture. That what we are going to see. Now, in the last class, what we have studied? We have studied about the atom, right? Atom. What is the atom? Atom, it contains the nucleus. In that nucleus, we are having the protons positive charge and the neutrons neutral charge and the electron negative charge revolving around it, that we have seen. Clear? Then how to identify the atom, that I was explained very clearly. The smallest particle which may or may not have the independent existence is known as the atom. Clear? Now I explained with very clearly with the which one, with the small family. In that family, the person who is having the 2H or 3H, those are not having any independent existence. Next comes to the molecule. Molecule means smallest particle which is having the independent existence, right? What is the meaning of the independent existence? Let's take 18 years of the son or daughter. He or she is having the independent existence without any help of their mother or father. They can go to the respective colleges and they can come to their respective homes, right? Clear? Now, the particles which is having the independent existence. Clear? Now that I was explained very clearly, hydrogen is an atom. Now it is not having an independent existence. Now it will be existence in the nature as a H2 molecule. Clear? Now next we are having the helium. Helium will exist in the nature as the He only. He only. Clear? Then after that we have seen about the ions. What is the meaning of ions? In that ions we have seen about the cation and anions. What is the cation and what is the anion? Cation is the loss of electron and anion is the gain of electron. Here, this we have seen very clearly. Then after that we have seen here, this is a proton, neutron and this is the electron, right? For given any molecule or for any given compound, how to identify? How to identify number of protons, number of neutrons and the number of electrons, that we are going to see. Now, I explained in the last class, I said you to find how many number of protons and then how many number of neutrons and how many number of electrons that are present in the H2. Clear? Here you can see, already I explained you. Now for the symbol of an element, we will represent as the X. This Z represents a which one? Atomic number, and A represents a atomic mass. Clear? Now how to identify the atomic mass? A is equal to what? Protons plus neutrons. Sir, how to identify the protons? I said you, atomic number will be equal to protons, number of protons of that element will be equal to number of electrons of that element. So if you want to find the number of neutrons for that any element or any compound or any molecule, that what you have to do? Just neutrons is equal to atomic mass minus proton. Atomic mass minus proton, if you do, you will get the number of neutrons. Number of neutrons. So now here for the H2O, what we can see? Oxygen, protons. Oxygen we are having 8 protons and hydrogen 2, right? So 2. Total 10. Now electrons also 10. But only the difference we will get it as in the neutrons case. Neutrons will get only 8. But oxygen it is, sorry, hydrogen it is 0. Hydrogen it is 0. That already I explained very clear. Okay, this is the basics of the last class that we have studied. Now, here today we are going to start our lecture of basics of the which one? Periodic table. In the basics of the periodic table, to understand very clearly, first I want to explain the atom and about its orbit. Already I think so you have studied in your lower classes. This is our nucleus. this nucleus contains protons and the neutrons. Then after the protons and the neutrons, we know this is a K shell. Next, this is a L, and this is a M. Clear? Done. Now here this first K shell contains 2 electrons. Clear? Next, L shell contain how many electrons? The L shell contain 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. K shell contain 2 electrons and the L shell contain 8 electrons. Clear? And M, it can accommodate how many? It can accommodate total 18 electrons. It can accommodate total 18 electrons. This is some basic representation we have to remember. So K can accommodate 2. L can accommodate how many? 8. M can accommodate how many? 18. This is some basics as of now. You just remember. Okay. But in our advanced level, when we start our actual lecture of the structure of atom, there we will never use the KLM. Okay, there we will use it as a n is equal to 1 orbit, n is equal to 2 orbit, n is equal to 3 orbit. There I will explain very clearly. But as of now, you just remember. Clear? Now, first we will go with the basic information of our periodic table. Already in the last class itself, I explained you very clearly what just up to our actual lecture start, just you try to remember the up to 30 elements. In the 30 elements, what I said you to remember. Here you can see this is which one? First one, this is a SRS block. Up to here, I said you to remember. These are the basic elements I said you to remember. Clear? Now this is a S block. Now this is transition elements D block. This is P block, and the below one is a F block. Clear? Now here, based on this, we are having this periodic table has been divided into how many types? This periodic table has been divided into 7 periods and 18 groups. 7 periods and 18 groups, right? Now we'll see. Here you are going to see how this has been divided. First we are going to see about the which one? About the periods. Here you can see about the periods. First period is the shortest period. It contains only 2 elements. It contains only the 2 elements. Starting element is hydrogen and the last element is the helium. Here, now second period can accommodate 8 electrons. Sorry, 8 elements. That it is starting with the which one? It is started with the lithium and it has ended with the neon. Now third period also it can accommodate 8 elements. Started with the sodium and ended with the argon. Next fourth 18, because here after potassium and the calcium, here from the D block elements will start. D block elements will start. So that's the reason 10 elements has been added. Total it has become 18. Clear? And next it is ending with the krypton. Next here longest period. This is rubidium and ending with the xenon. Here cesium and ending with the radon. Here francium and it is ending with the 1 OG. This UuO they are given. Here it is a OG. Here then you can see here. First here in the if they have given the period number, then how to identify how many elements are there in that period? Just one trick I will say. If you remember that one, it will be very clear for you. Remember the noble gas elements. What are the noble gas elements? Helium, neon, argon, krypton, xenon, radon, and the ozone. These are the noble gas elements, right? Just and the noble gas elements. First, we are having every element or every compound want to try to attain the noble gas electronic configuration that we know. What? Every element or compound or ion want to try to attain the noble gas electronic configuration. In this noble gas electronic configuration, what it should be there? Its octet should be complete. What is the meaning of octet? Octet means 8 electrons it should be there. Now, but helium, it will not show the octet configuration. It will show the duplet configuration. It will show the which one? Duplet configuration. It will show the duplet configuration means 2 elements. Then octet 8, duplet. See here, helium configuration is 2. First period contain 2 elements and the second period contain how many? 8. Add for these 2, add the 8. Now neon atomic number has came. For this neon, again you add the 8. Argon atomic number it has came. For this argon, add the 18. 36. Krypton atomic number it has came. Now krypton, add the 18. You got the xenon 54. Its atomic number it has came. For this xenon, add the 32. Here 86. Radon it has came. Next add the 36. Here it got the OG. Here remember the magic number. What is the magic number? 2, 8, 18, 18. Next 32. Sorry. 8. Sorry. 2, 8, 8, 18, 32 and 30. This is the magic number we have to remember. If you remember this one, you will not get any problem to identify the any element's atomic number. That again I will explain very clearly when I start the classification of periodic table. Which one? That video. We are going the series wise, line by line or one by one. The classes will come. Okay. Next, we'll move with the valency. This is a very key role. If you remember, but if you remember this valency, you will not get any difficulty in identifying the how the bonds are forming while writing the molecular formula, identifying of the bonds, clear, ionic bond, covalent bond, clear. This is the valency will play a very crucial role. What is the meaning of the valency? Valency denotes the combining capacity of the atoms of an element. It is equal to the number of electrons of an atom can be donated or accept or share. Sir, I did not understand. Okay, I know. I will explain very clearly for you. Better first we'll take the which period elements means second period elements will take. Second period elements. You can see here. What are the second period elements we are having? Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. Okay? Okay. Sir, first I will take the lithium. Second I will take the beryllium. Third I will take the boron. Next carbon. Next nitrogen. Next oxygen. Next fluorine. And this is neon. Neon is the noble gas elements. Its octet is complete. Every element wants to attain the noble gas electronic configuration we know. Now you see, what is the valency of the lithium? Lithium atomic number is 3, 4, boron 5, 6, 7, 8, 9 and this is 10. Clear? Here if you go it for the lithium, I want to draw the atom of the lithium. This is nucleus. This lithium, what I said, this lithium nucleus contain how many protons? Atomic number will be equal to its proton, I said you right. So 3 protons will be there for the lithium. Okay, and the neutron is neutral charge. This is the, now go with the which shell we are going to see. Now first one is a K shell. So K shell of the which one? Lithium. We are having only 2 electrons. K shell can accommodate 2 electrons. Already I explained. Go to the lithium. Next K L shell. L shell it can accommodate how many electrons? 8 electrons. So Lithium, it is having only one electron because its atomic number is 3. It should have only 3 electrons. 1, 2, 3. Done. Next, go to the beryllium case. Beryllium case also same. 4 protons, and the K shell it contains 2 electrons, and L shell it contains 2 electrons. Done. Line wise, if you see, now in the K shell, 2 electrons is fixed for all. In the K shell, how many electrons it is fixed? 2 electrons is fixed for all the 3D elements. But only what it is different, the difference we are going to see only in the which one? In the L shell. In the L shell, lithium is having, in the L shell, lithium is having only 1 electron. Beryllium is having 2 electrons. Boron is having 3 electrons. Carbon is having the 4 electrons. And nitrogen is having the 5 electrons. And oxygen is having the 6 electrons. And fluorine is having the 7 electrons. And the neon is having the 8 electrons. This we know, right? Here, what is the meaning of the valency? Here you can see it is equal to the number of electrons of an atom can donate or accept or share. Can donate or accept or share. You can see. I will write in this manner. So I hope this is clear for you. Now I will draw the Lewis dot structure of these elements. How to draw the Lewis dot structure of these elements? Now you see. I hope you got it. Now in the L shell how many electrons, K shell how many electrons you got? Now you see. Now we will see the Lewis dot structure of the different elements. Already I explained. Lithium contain what? Lithium in a K shell it contain all these elements. K shell electrons are common 2. Which is different? L shell electrons are different. For the lithium, valency electron or L shell electron is 1. Next, for the beryllium, valency electrons or L shell electrons are 2. For the boron, it is 3. Carbon, it is 4. Now, nitrogen, it is 5. Nitrogen, it is 5. Oxygen, it is 6. Fluorine, it is 7. Neon, its octet is complete, 8 electrons. Sir, what is the meaning of the valency? Sir, you are saying that this is a valency. Sir, how I can know that lithium valency electron is 1? So, in this manner also I will explain. In the another manner also I will explain. This is a nucleus. Okay. First shell is a K shell. This is L shell. Okay. Now you see here for the lithium we are having 2 electrons in the K shell. When it comes to the L shell it is having only 1 electron, right? This last shell we call it as a valency shell. This last shell we call it as a valency shell. Clear? I hope it is clear for you. Last shell we call it as a valency shell. Now we'll see. Now we got to know lithium is having the 1 valency electron, beryllium is having the 2, boron 3, carbon 4, nitrogen 5, oxygen 6, fluorine 7, neon 8. Then after that, how this will share or how it will accept or how it will donate. Now we'll see. Best well-known example for you, I will take it for you the NaCl. Best well-known example, you know, right? And the next another well-known example I will take you, formation of the Cl. You know, if I ask, sir, what is the bond between NaCl means, blindly you will say, sir, ionic bond. If I ask, sir, what is the bond between Cl2 means, you will say, sir, covalent bond. Sir, covalent bond. How the NaCl is forming the ionic bond? How the Cl2 is forming the covalent bond? Now we will see. Here, this Na, how the ionic bond will form if I ask, sir, mutually sharing what? complete transfer of electron from the cation to anion. Clear? Complete transfer of the electron from the cation to anion. Why the cation is transferring the electrons to the anion? Now you see. Here sodium, what I said, every atom or every element want to attain the noble gas electronic configuration, right? Or noble gas electronic configuration or zero group elements configuration, it will attain. First, this Na plus and the Cl minus. Due to this transferring of electrons only, this will form the anion. Now you see, Na, what I said in the last class, I explained very clearly. Plus indicates loss of electron. This negative indicates gain of electron. Loss of electron, gain of electron. This Na plus, you can see, this is normally sodium atomic number is 11. Sodium atomic number is 11. This atomic number and how many number of protons are there, that many number of electrons it should be there. I explained very clearly. Atomic number will be equal to number of protons will be equal to electrons. Here what it is happened, one electron has been lost. For this sodium, Z is equal to 11. Protons are 11, but electrons are 10 means. Now electrons are 10 means it has reached to the noble gas electronic configuration, right? Octet electronic configuration. Neon also will have the 10 electrons. Neon also will have the 10 electrons. So it has reached to the noble gas electronic configuration. Now Cl minus you take. Cl minus, what I said, minus means gain of electron, I said, right? Atomic number of the chlorine is 17. Protons will be 17. And the electrons will be 18, right? 18 means it has reached to the which one? Argon configuration. Argon, it is having the 18 electrons. I explained very clearly. Clear? So both has become the which one? Both has become which one? Very stable configurations, right? You can see sodium by the loss of one electron, it is becoming stable. Chlorine by the gain of one electron, it is becoming stable. So that due to the charge between this plus charge and the negative charge, and the attraction force will be there. Attraction force will be there and they will form the bond. Clear? This panel anionic bond will form, and when it has been dissociated, those all it will become stable. Now comes to the chlorine case. How the covalent bond will form? Covalent bond will form on the basis of mutually sharing of electron. That we know. Normally chlorine, fluorine, chlorine, bromine, iodine. These are halogens, right? Fluorine contains 7 valence electrons. Same chlorine also 7. Bromine also 7. Iodine also 7. Now you see 1, 2, 3, 4, 5, 6, and this is 7. And another chlorine. 1, 2, 3, 4, 5, 6, and this is 7. Now you can see here. Here, this chlorine to completes its octet. Means this chlorine to completes 8 electrons. If it is having, it will complete its octet. That we know, because it will reach to the noble gas electronic configuration. So this chlorine to complete its octet, what it should have? It should gain 1 electron. So this chlorine 1, what will ask? Oh, chlorine 2, you give me 1 electron so that my stability will be completed. And this chlorine 1 and this is chlorine 2. This chlorine 2 also will ask, oh, chlorine 1, you give me 1 electron of your 1 so that my stability will be completed. So what they will do, you know, so instead of completely giving, what these two mutually understand, and they will say, instead of my electron to give to you and your electron giving to me, so what we do? Mutually we will share our electrons. Mutually we will share our electrons. So this chlorine of this one and this chlorine mutually share the electron in between these two, and by that it will form the bond. Clear? By that what we got to know? One bond contain 2 electrons. By this we got to know that covalent bond. In that covalent bond, one bond contain 2 electrons. Is it clear? Then this is about the how the valency will work. Valency electrons are valency. And you may get it out. Sir, here you have explained nitrogen, it is having 5 electrons, 5 valency electrons. Will the nitrogen will form the 5 bonds? Sir, here the Oxygen you are having. Sir, oxygen is having the 6 valency electrons. So, will it form the 6 bonds? No. Here, nitrogen, it will not form 5 bonds. Why? Because you can see nitrogen, every atom, element, compound, what I said, want to attend the noble gas electronic configuration around itself. That nitrogen around itself, it should have the 8 electrons so that it will become stable. Nitrogen, to reach the neon electronic configuration, how many electrons it should gain? It should gain only 3 electrons. So that's the reason nitrogen, it will form the triple bond. One, this nitrogen normally it will have how many? Nitrogen normally it will have 5 valency electrons. Clear? 5 valency electrons it will have. So 3 electrons it has gained from the another nitrogen, 3 electrons it has gained from the another nitrogen. Both has become stable and 8 electrons are there in between 2 nitrogens. How? Sir, how the 8 electrons are there? Now you see. Here 1, here 2, here 3, here 4, here 5, here 6, here 7, here 8. One nitrogen, 8 electron octet complete. So this nitrogen also same. 1, 2, 3, 4, 5, 6, 7, 8. And comes to the oxygen case. Oxygen, same. Double bond. How the oxygen is forming the double bond? You can see. Oxygen case, 6 valency. Oxygen case, 6 valency. Now, here 1, 2, 3, 4, 5, 6, 7, 8. Each oxygen octet has been formed. Here, in this manner, we have to study. This is, even though it is having the 5 valency, it will not form the 5 bonds. So, around its octet, it should be completed. Then, next we will move to the important periodic properties. So, here, what are the important periodic properties that we are going to study? Actually, the periodic properties we are having atomic size, ionization enthalpy or ionization potential, electron gain enthalpy, electronegativity. This all we are going to start or we are going to study when our basic or our chapter start. This is only the basics, right? So no need of going to that much basic advanced level, but just have some idea how the atomic size will form. See here how the atomic size left to right in the periodic table, what I said, 7 periods we are having and 18 groups we are having. So 7 periods means left to right. If you go to the periodic table, this is left to right. Then this is top to bottom. If you go into the periodic table, this terminologies will be used. If we are talking about the periods, we will say left to right. If we are talking about the groups, we will talk it about the top to bottom. Okay. Left to right atomic size will be decrease. Top to bottom atomic size will be increase. How sir? Why sir? I will explain. Okay. Next, metallic character. As of now, metallic character and the non-metallic character means you just remember this one term. What is the one term that you have to remember? The one which readily loss of electron will behave as a metal. Okay. The one which readily loss, the tendency to lose the electron will behave as a metal. Now, non-metallic means tendency to gain the electron. The species or elements which are ready to gain the electrons will behave as a non-metals. Okay, this you remember. Okay. Now first we will see with the what is the meaning of atomic size and how we are going to study this atomic size. Now we'll see. Atomic size. What is the meaning of atomic size? Distance between the center of the nucleus of an atom and the outermost shell. Sir, what is the meaning of the outermost shell? Just now I explained you. If I was talking about the, better I will go with the well-known example of your sodium. Sodium, if I take, this is a sodium nucleus. Sir, sodium is having the 3 shells, right? One is K shell, one is a L shell, and the next one is a M shell, right? K, L, M. Clear? Sir, for the sodium atomic number is how much? Sodium atomic number is 11, sir. So 11 means how many electrons it should have? 11 electrons it should have. So 2 here, 8 here, and 1 here. Clear? 2, 8, 1. Then 2 electrons, 8 electrons, and the 1 electron. 2, 8, 1. Clear? Here, sir, for in the lithium case, you have said that lithium case, if I talk, lithium it is having how many electrons? 3 electrons. K shell and this is L shell. For the lithium case, 2 electrons will be in the K and 1 electron will be in the L. So for the lithium case, if I talk with the lithium case, in the lithium case, this L shell will be the outermost shell or valency shell. But if I talk about the sodium case, this M shell will be the outermost shell or valency shell. Okay? Why it is happening like that? I will explain very clearly. But what is the meaning of the valency shell? I hope you are clear. The last shell of that element is the valency shell or outermost shell. Okay, don't get confused. The terminologies in our chemistry, it will make you somewhat difficult, but remember, outermost shell it is same and the valency shell it is same. Now here from this nucleus, this electron, this is the nucleus, right? From this nucleus, electron, this outermost electron distance, we call it as the atomic radius. You can see this is the nucleus and the outermost shell electron, that distance we call it as the atomic radius. Here atomic radius can also be defined as the half of the internuclear distance between the combined atoms in the molecule. If you take the molecule, H2 molecule you take, this is molecule, mutually share the electrons, right? Here, now this distance between these two nucleus will be the what? Atomic radius for the molecules. Then, now we'll go here. Now, first we are talking about the which one? We are talking about the groups. Means we are talking about the top to bottom. When we are talking about the top to bottom, I was explaining about the first group elements. Okay, about the first group elements I was talking. In the first group elements, here we are having the what? Hydrogen, lithium, sodium, potassium, rubidium, and the cesium. Hydrogen atomic number is 1, lithium atomic number is 3, sodium atomic number is 11. Next, potassium 19, 37, 55. You can see already explained you. I hope it is clear for you. For the lithium, we are having only 2 shells. If you go for the sodium, one shell has been increased. So, K L only for the lithium. For the sodium case, K L M. Now, potassium case, K L M N. Done. Now, rubidium case, K L M N O. Done. Now, word on cesium case, K L M N O P. K L M N O. Done. You can see here what is the thing you have to remember and what you have to see here. Top to bottom, when we are moving from the top to bottom, when we are moving in the periodic table, what happened to the atomic size? Atomic size is increasing, right? Okay, you can see, just nominally you can see. Shell is increasing. One new shell is, electron is adding into the new shell. So obviously if the new shell is added, atomic size will be increased. See, lithium size is this much only. Now compared to the lithium, sodium size is high. Next, potassium is high. Here, by this you can see. For the lithium, this is size. Now, sodium, this is size. Next, potassium, this is size. Next one, rubidium, this one. Now, last one, cesium. Here, what the general way we can say, top to bottom in the periodic table, what atomic size increases. Atomic size increases. Why? New electron will be added in the new shell. That's it. Okay. Now, next we'll talk across the period. Across the period means left to right. In the left to right, already I explained you very clearly. What? Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. If you take K shell electrons are 2. In all the cases, K shell electrons are 2. You can see. But in the L shell electrons, we are getting difficult. L shell electrons, we are getting difficult. So, if the L shell electrons are getting difficult, why the atomic size from the lithium to fluorine, if you go, why it is decreasing? Now we are going to see. Now, here you can see atomic radius 152, 112, 88, 77, 70, 66, 64. Atomic size is decreasing, right? Sir, why it is decreasing? Now I will explain very clearly. Now listen. Sir, for first I will go with the lithium case. Okay? Lithium we are having the 3 protons. Done? And it is having the how many? 3 electrons. Now comes to the oxygen case. Oxygen it is having what the oxygen it is having? So oxygen case if you see, oxygen it is having 8 protons. 8 protons oxygen is having. And how many electrons oxygen will have? How many electrons oxygen will have? Total 8 electrons. So in the last shell it will have 6 electrons. You can see L shell 6. Now this proton is positive charge. Electron is negative charge. We know this proton is positive charge. Electron is negative charge. Then proton and electron attraction will be there or repulsion will be there. What it will be there? What? Attraction will be there. Opposite charges will attract, same charge will be repelled. So this proton is positive charge, electron is negative charge. So this will attract. So these 3 protons will attract these 3 electrons. But when it comes to the oxygen case, you see, how many? Here we are only 3 positive charge. But here we are having how many? 8 positive charge. Compared to the 3 positive charge pulling capacity, 8 protons will have the higher capacity to pull the electrons towards itself, right? See, lithium it is having only 3. So it is pulling the 3 electrons very slowly. But here we are having the 8 protons. 8 protons is having the high nuclear charge. Means it is having higher capacity to pull the electron towards itself compared to the lithium. Compared to the lithium, what oxygen will pull the valency electrons. These valency electrons towards itself very strongly. When this nucleus of this oxygen is pulling these electrons very fastly, means what happened to the shell size? Shell size will be decreased, right? As the attraction is happening before this, you can see before the nucleus is here and the electron valency shell of the oxygen is here. As the nuclear charge, what it is doing? It is pulling. It is pulling this electron, means size is decreasing, right? Size is decreasing. Clear? In that manner, left to right, if you go, electrons are adding in the same shell. Electrons are adding in the same shell. You can see here 1, 2, 3, 4, 5, 6 L shell. Electrons are adding in the same shell. When the electrons are adding in the same cell, what it will happen? In the nucleus also 1 proton will increase. Nucleus also 1 proton will increase. If in the nucleus also 1 proton will increase, means what it will happen? Nuclear charge increase. If the nuclear charge increase, means valence shell will come to closer and the atomic size will be decreased. Clear? So that what we have studied, left to right, size decrease, top to bottom, size increase. That's it. Clear? Now we'll see with the metallic character. What I said, what is the metallic character? Only one thing you have to remember, I said what? If any species or if any elements are ready to lose the electron, that it will be behave as a metallic nature. That it will behave as a which one? Metallic nature. So which one is ready to lose the electron and which one is ready to gain the electron? Now we'll see. Here those elements which have tendency to lose their valency electrons of the outermost orbit and form the positive ion are considered as a metals. You can see, let's take example. Your well-known example, what is that? Sodium. Sodium, normal sodium atomic number is 11. It contains K shell contain 2, L shell contain 8 and M shell contain 1. Done. This sodium, by the loss of electron, it has become positive. It has reached to the noble gas electronic configuration. Already explained about the neon. For the magnesium case, if you take 282, magnesium will be lost 2 electrons. It will not lose 1 electron. Why? If it is lost one electron, it will not reach to the noble gas electronic configuration. Why? Magnesium, if you cross check, 282. Here, let's suppose it has lost one electron. It will reach to the Mg place. What it will be there? 281. This is sodium electronic configuration. Every element was got in the noble gas electronic configuration or octet electronic configuration, I said. So magnesium, it should readily lose 2 electrons. If it is readily lost 2 electrons, it will reach to the noble gas electronic configuration. Next, Al, aluminium. Aluminium will readily lose the 3 electrons to reach become Al plus 3. Why? If it is readily lost the 3 electrons, what it will happen? It will reach to the noble gas electronic configuration. Clear? Done? Now, this is about the metallic character. Now comes to the non-metallic character. What is the meaning of the non-metallic character? In this non-metallic character, what you are going to see and what we are going to see in the non-metallic character, here, those elements which have tendency to gain the electron. Already I said, loss of electron will behave as a metal and the gain of electron will behave as a non-metal. Clear? See, chlorine case. Chlorine by 287, 17 electrons. If chlorine, if it is taken one electron, it will readily reach to the which electronic configuration? Argon electronic configuration it will reach. Now, here, sir, it has reached to the argon electronic configuration. Now, if you cross check with the which one? If you cross check with the, sir, another example, sulfur. Sulfur, it is having 2, 8 and 6. Sulfur, to come to the argon electronic configuration, it should gain the 2 electrons. It will become S minus 2. It should take the 2 electrons, right? If chlorine is taking 1 electron, now the charge is Cl minus. Sulfur is taking 2 electrons, it will become minus 2. This minus 2 indicates that it has taken the 2 electrons. This minus 1 indicates that it has gained the 1 electron. Clear? Now we'll see just a generalized way how to remember group 1, group 2, group 13, group 14, group 15, group 16, group 17, group 18 elements. Just basic. First, this is the third period element: sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine and argon. I want to explain or I want to ask for you, these are the third period elements, right? These third period elements, left to right in the periodic table, for you a question, comment in the comment section. Third period elements, left to right in the periodic table, what happened to the atomic size? Will increase or will decrease, will remain same, no change. This is the option that you have to see. Here electrons you can see, and you can see here this sodium will readily lose the, here you can see this sodium will readily lose the 1 electron and it will become Na plus. Magnesium will readily lose the 2 electron, it will become Mg plus. Aluminium will readily lose the 3 electron, it will become Al plus 3. Sodium, by the loss of 1 electron, it will reach to the noble gas electronic configuration. That's the reason this is metal. Magnesium will be readily lose the 2 electrons. That's the reason it has become metal. Al, by it will readily lose the 3 electron. That's the reason it has become metal. Already I explained it. The one which readily lose the electron will behave as a metal. Next, silicon. It is intermediate. It will behave as a metalloid. Now, phosphorus, you see. Phosphorus, it is having the unique way. Phosphorus, it can gain the 3 electrons to reach the argon electronic configuration. Clear? Instead of losing the 5 electrons, phosphorus, if it is gained the 3 electron, it will reach the argon electronic configuration. That's the reason this is non-metal, because it will readily gain the 3 electrons, so that it will reach the argon electronic configuration. Next, sulfur. Sulfur, it can readily gain the 2 electrons, so non-metal. Gaining of electron, non-metal. Chlorine also gaining of electron, non-metals. So this is noble gas. Clear? I hope by this I was explained very clearly how the metal, non-metal, how the atomic size and how the valency electrons and in that valency electrons, how the ionic bond will form, how the covalent bond will form. That all I explained very clearly, and we will meet you in the next video. Okay.